Today we are looking at algebra basics, expressions, and polynomials. So feel free at any point to stop me if you want me to explain something a little bit more, or anything like that, okay?
Okay.
So we're going to start with the number line and signed numbers. To add numbers that have similar signs, you simply just add them as we've seen in the earlier lessons and keep the same sign. So there's nothing brand new about that. To add numbers with unlike signs or with different signs, I want to find the difference and then use the sign from the target number. And you'll see what I mean as the lesson progresses. So to subtract signed numbers, you simply change the operation to addition and then change the sign of the numbers that you're subtracting. And again, we'll see examples of that as the lesson progresses. Signed numbers include 0, and by signed, the book simply means either a positive number or a negative number. Okay, so signed numbers include 0, all positive numbers, and all negative numbers. 0 is neither positive or negative, so it's essentially neutral, and it's right in the middle of the number line. On the number line, the positive numbers are shown to the right, as you see here. So from 0 to all the way up to positive infinity. And then the negative numbers are shown to the left from 0 all the way up to negative infinity, okay? A positive number can be written with a plus symbol. And if a number has no symbol at all, we just assume that it's positive. Negative number will always have a minus sign preceding it. So if you're representing a negative quantity, there are no assumptions made. You have to always precede that number with a negative symbol. The signed number produces or provides two important facts. The sign tells you the direction from 0, and then the number tells you the distance from 0. So for example, -5 lies exactly 5 spaces to the left of 0, and +4, or just simply 4, lies exactly 4 spaces to the right of 0. In terms of adding and subtracting signed numbers, you can use the number line to model the addition or the subtraction operation. So in this example, 1 plus -4 equals -3. And you would, let me zoom in so you can see. You could draw your number line, starting at 1, move 1, 2, 3, 4 spaces until you get to -3. You're recording the digit when you stop your count, right? So again, the example is telling us to add 1 to -4. So you would start at 1 and you would count down the number line exactly 4 spaces, because it essentially, let's go back to the slide. Remember we said that when we're conceptualizing -5, it's exactly 5 spaces to the left of the number line, right? So here, to add 1 to -4, you would just simply move 1, 2, 3, 4 spaces, okay? Or -4 spaces on the number line, and read off the value that is in the position where you stopped. And in this particular answer, in this particular instance, that value happens to be -3. We're given another example here of -5 plus 4. Same thing, you would start at -5, and it's telling you to move +4 or +4 spaces. That implies to your right, right? Because it's positive. Any movement to the right will always be positive. Any movement to the left will always be negative. So we're at -5, and we're being asked to move 4 positive spaces to the right, or 4 spaces to the right. So we start at -5, and we count 1, 2, 3, 4, and then we read off the value where we stopped, and that answer is -1. Or you can just think of this as, let's say you're an accountant, okay, and you're dealing with a client's account and you see that their account is in the red by -$5. Well, if they added $4 to the account, it would bring the account up to -1, right? And that just means that they're -1 space away from not owing the bank anything, or essentially -1 spaces away from being neutral or being at 0. So again, we start at -5, and then we just simply count 4 spaces over to the right and then read off the value where we stop. Here, we're being told to add -2 to -3. So -2 plus -3 should give you -5. So anytime you see two negative numbers being added together, just think of it as the same as adding two numbers as you would do normally, but then don't forget the negative sign. So if we imagine that these negative signs weren't there, 2 plus 3 is 5. Right? But in this case, because we have -2 plus -3, we would indicate that this 5 is negative. Or you can go to the number line and start at -2, okay? So on the number line, your starting point should always be the first number mentioned, okay? If you've noticed in all the examples so far, with this one, starting point on the number line was 1, since it's the first number mentioned, right? With -5 plus 4, our starting point was -5, and then we counted 4 places over to the right. So here, -2 plus -3, our starting point is going to be -2, and then you simply want to count 3 spaces to the left. Why? Because we're dealing with -3, right? So 1, 2, 3, read the value at that spot, it's -5. Again, two different ways of approaching addition when you see when you see that both values are negative. You can just treat it as a regular addition, but remember to add your negative sign, or you can just go to your number line, begin with the starting value. So here our starting value is -2, and go back to the question and read. Now it's telling you to -2, add -3. So you would just count 1, 2, 3 spaces over to the left. Or you can reimagine your role as an accountant. So let's say you are doing the books for a customer and you see that they're in red by -$2 on day 1. And then the next day they decided to buy a coffee for $3. Well, they're starting at -2. So if they spent $3 that they don't have, well, now they're at -5, okay? So here's a test tip for you. You can just assign key at the bottom of the online calculator, and this changes a positive to a negative number and vice versa. And this is the on my calculator. Remember, my version is a little bit older, but some of the keys are similar. But whenever you get the calculator, you'll see this. I don't know if you can, let me try to bring it. There's too much glare from the window. I don't know if you can see right here. This is the button that you would hit if you wanted to, let's say, enter -3. You would press this and then 3, okay?
Okay, I see it. I have the calculator.
Oh, you do? Okay, great. Okay.
Yeah.
To add without a number line, you would follow these steps. If numbers have similar signs or like signs, you want to add the numbers and keep the signs the same. Okay, so essentially in the example that we just saw with -2 plus -3, since they're both negative, just add the numbers. So 2 plus 3, 5, and then keep the sign the same. -5 would be your answer. Or in the case where you see 3 plus 3, you have two positive numbers. 3 plus 3 is 6. There's no sign change. So that's all this is telling you. And then if the numbers have dissimilar signs or unlike signs, you want to find the difference between two numbers and then use the sign of the larger number. Okay, in this example, we're being told to add 15 plus negative 25. Let me zoom in so you can see this better. Okay, so 15 plus negative 25, right? Since the numbers have unlike signs, you would simply just subtract 25 from 15, which is 10. And then you would use the sign from the larger number. In this case, that's 25 to give you negative 10. I do want to make a note here. There's a difference between the value of a number and, well, in this instance, it's telling you that 25, negative 25 is the larger number. But in reality, if you go back to your role as an accountant and you have two separate clients, one has $15 and one has negative $25. Well, obviously we know that 15 in reality is the larger number, right? So negative numbers, when we go back to the number line, negative numbers are always smaller than positive numbers. But it's telling you to consider the value, like pretend that that number, that negative sign is not there, and then consider the value of the two numbers. So if we pretended that this negative sign wasn't there, 25 would be the larger number, right? So you would, again, like the instructions say, since these two signs are different, you would just simply subtract or pretend like this negative sign is not there, subtract 25 from 15. And since we're pretending that the negative 5 is not there, and we're considering the two numbers, the one with the larger value is 25, right? So then you would look at the sign next to 25 and it happens to be negative. So your answer has to be negative, okay? You can think of this as a client having negative $25 in their account, and then they get a transfer of $15. Now they're still not out of the red, but they're definitely further, or they're closer to being positive than they were, right? Before they received the $15 transfer. Now they're at negative 10, okay? So that's what this is trying to tell you here, that if the numbers have unlike signs, find the difference between the two numbers and then use the sign of the larger number. But obviously you want to reflect the negative sign in your answer. So just kind of keep that in mind. So subtraction is the opposite of addition. To rewrite a subtraction problem as an addition problem, you want to change the operation symbol to addition and then change the sign of the number that you're subtracting. Then you want to apply the rules for adding signed numbers. Okay, that's a mouthful, but you'll see what that means in a second. So for example, we're being asked to subtract 3 from negative 8. So you want to change the operation symbol and the sign of the number that you're subtracting. So you would put negative 8 in parentheses, okay, just to kind of make your life easier. And so that you can remember that you're dealing with a negative number, put negative 8 in parentheses, and then put an addition sign. And then you would add 3 plus negative 8. There was a typo in the book. That's why you see this here, because the book was showing 5, but that's the wrong answer. It should be negative 5, okay? We're adding, because if we go back to your role as an accountant, let's say that your client had negative $8 and then they transferred $3 into their bank account, right? So essentially what's happening is that $3 is being added to that negative state, right? And they're still not in the clear, right? They're still not at 0, you know, or a value higher than that. But we have to recognize that they did add $3, or they did deposit $3 or whatever, and that you can consider that as an addition, right? So that's what this, let me zoom back out. That's what this is trying to tell you here. is that when you're subtracting, you still want to treat it like an addition, but keep track of that negative sign, okay, and how it's being affected by whatever it is that you're adding to the negative number, okay. And I think the easiest way is just to think in terms of dollars and cents, okay. You can use the same rules to combine several signed numbers, okay. So in this example, I'm being told to add -5 plus 6 plus, -5 plus 6 minus 4 minus a -2. And you can see here that writing the -2 in parentheses is helpful because it's helping you differentiate between the negative number, which is the -2, and the operation, which is subtraction, okay? There are several ways to approach this. You can rewrite each subtraction term as addition, and then you can add the positive terms. Anytime you see two negative numbers, I think we covered this already, but anytime you see not two negative signs right next to each other like this, it automatically becomes positive. So I drew this in there to help you see where this +2 is coming from, okay? So 6 plus 2 is 8. So those are our positive numbers, right? Group the positive numbers. 6 is our first positive number, and our second positive number is going to be this 2. Why? Because there's two negative signs right next to each other, okay? So 6 plus 2 is 8. Then you want to group your negative numbers. We have -5 and we have -4. -5 plus -4 is -9. And then you would simply just combine your results. So 8 plus -9 is -1, okay? Or if you were at -$9, you added $8 to your account. You're now in a much better state. You're still not at 0, but you're not at -9 either, right? You're now at -1. Okay, so, or you could just go through the motions. -5 plus 6 is 1. And that's just thinking of it in terms of if you were at -5, you added $6 to your account. Now you have $1, right? Because you've cleared out that negative balance. Now you have $1. 1 minus 4 is -3. So you had $1. You bought something that was $4. Now you're back in negative territory, -3. And then you see these two negative signs next to each other. That immediately means that you're adding. So -3 plus 2 is -1. Okay, so two different ways of approaching this. You can just go down the line, or if you're more comfortable, just group the numbers with like signs and then combine your results. So start with your negative, -5 plus -4, or whatever. You could start with your positive, whatever you feel like doing. So group your positive numbers first, group your negative numbers, and then combine, like was done in this example. Okay. So practice problems on page 838 to 840. Multiplying and dividing signed numbers. In algebra, multiplication is not shown using the multiplication sign because the symbol could easily be mistaken for a variable x, and we've seen examples in other lectures where we're using x as a variable. So instead, when you're looking at a multiplication problem, it'll be shown using a dot or by placing two numbers next to each other to avoid confusion. And then one or both of the numbers can also be enclosed in parentheses. So for example, here 5.6 means 5 times 6, or if it's written like this, -5, and then we have 6 in parentheses, that's telling you to multiply -5 by 6, or you could have both numbers in parentheses. And so these are all three of these methods of writing the same thing. All three of these are methods of writing the same thing, and they all mean -5 times 6, okay? Division can be written with the division symbol, but it's usually shown with the line that means divided by. And so for example, the expression 20 divided by -5, written as 20 with the division line, and then -5 means 20 divided by -5. So does 20 / -5. Okay, so when you're multiplying or dividing signed numbers, use the following rules. If the signs are the same, the answer is positive. So in this case, if there was a negative here, -20 divided by -5, the answer would be 4. You would simply just drop the negative signs. Okay, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. So in this example, 20 divided by -5 is -4 because the signs are different. Okay, and that's all this is telling you. This example, we're being told to multiply 4 by -25. I want to make a note here. If you saw a negative operation between this -25, so if you saw 4 minus and then -25, don't multiply, okay? That's telling you to subtract 4 from -25, okay? But they're written close to each other and there's nothing in between them. So you know that that's multiplication. So pay attention to that when you're working on these. If there's nothing in between, if there's no operation, remember we discussed what our operations were sometime last month, or I think it was even one of the first classes. Addition, subtraction, multiplication, division, those are your operations. This is a negative sign. So this is, you wouldn't consider this an operation, it's the negative sign. So because the two numbers are written together like this, you know that you're being asked to multiply, or the operation in this case is multiplication. Okay, so what you want to do is multiply the numbers only. So 4 times 25 is 100. And then you determine the sign. And since the signs of the numbers are different, the answer is negative. Okay. So again, you always want to give, I don't want to say high priority, but you always definitely, the negative sign is king when there's no other, when you're dealing with two unlike numbers, okay? So you're dealing with a negative number and you're dealing with a positive number, the negative sign is going to be king. If this was -4 times -25, the answer would be positive 100 because you would just drop the two negative signs, okay? So there are lots of different considerations to be made when you're adding, subtracting, dividing, and multiplying. So back to your, I hope you're making your little notebook of rules. So these are some of the rules that you would want to write down for multiplication and division. Okay, so in this example, we're being told to divide -160 by -8. You simply just divide the numbers. 160 divided by 8 is 20. And then you determine the sign. And since the signs and the numbers are the same, your answer is going to be positive. A problem may contain more than 2 factors. So remember that each pair of negative factors will equal a positive product. So if there is an even number of negative terms, the product will be positive. And if there's an odd number of negative terms, the product will be negative, okay? And an easy way to remember this is if something is odd, we usually consider it negative. So that's an easy way to remember that. Like if you have a group of numbers and you count them, in this example, we're being told to multiply 5 times 6 times -1 times -2 times 2. So you can simply just drop all the negative signs and just multiply across. You get 120. And then because you counted the number of negative terms, 5 numbers, but 3 negative terms. So -5, -1, and -2. Okay, -5, -1, -2, that's 3 negative terms, and 3 is an odd number. So your answer is going to be negative. So what you need to be counting is the number of negative terms, okay, not the sequence of numbers itself, okay. I approach these differently. That's usually I would just go -5 times 6 is -30. -30 times -1 is +30 because you're multiplying two negative numbers. +30 times -2 is -60. And then -60 times 2 is -120, right? That's a different approach. So let's go with the approach that the book is telling you, right? So multiply 5 by 6 by 1 by 2 by 2, you get 120. And then since you have 1, 2, 3 negative terms, just add a negative sign to your final answer, which I think is a lot easier than the approach that I.
Okay, so if it had, let's say, 4 negative numbers,
Mhm.
then it would just be positive. It would just be 120.
Yeah, like if so, let's
Okay.
say 6 was let's say 6 was negative. Good question. So
Mhm.
let's say 6 was negative, then your answer would be positive 120. Yeah.
Okay. All
Yeah.
right. That's okay. I get it now.
Okay.
If it's odd, it's negative. If it's even, it's positive. Okay.
Exactly. Yeah.
All right.
Good question. So when a problem contains more than one order of operations, okay, do the multiplication and division operations first, and then you want to work from left to right, and then do the addition and subtraction operations last, also working from left to right. If a problem contains division presented with a division bar, you want to do any operation above and below the bar first, and then divide, okay? So let's zoom in on this example. We're being told to multiply -4 by 6 and then subtract that from 3 plus -9 divided by -2. So all these, this instruction right here is telling you is that you want to pay attention to how the numbers are grouped, right? So if you divided this, let's say you decided to multiply -4 by 6 and then subtract 3 and then add 9 and then divide everything by 2, your answer would be wrong. Okay, you want to pay attention to how the numbers are grouped. And you can see here that this division sign only applies to these two numbers right above it. It doesn't apply to what's on the left here. Okay, so you want to start, and you always want to start with multiplication first. So -4 times 6 is -24. Okay, so we've done our multiplication first. And then you're going to subtract -24 from your fraction here, okay? So -24 minus 3 plus -9 divided by 2. Well, what are we going to do? We're going to work on the numerator first. And we're going to subtract 3 from -9. And what do we know concerning our rules with dividing like numbers? We simply just drop the negative sign, right? So now we're dealing with 6 divided by 2, which is 3. -24 minus 3 is -27, okay? And this negative sign just distributes across, okay? So you would read this, or you can think of this as -24 minus 3, right? Okay.
Okay, so that's not really a fraction. That's really just division.
This here is your fraction.
Yeah, so when you simplify the fraction -6 over 2, basically you're dividing 6 into 2. This is 3.
Right. And so,
Okay.
yeah, you're just
Then minus that from -24. And so therefore it would be -20. No, I was gonna say -21, but I think I'm wrong. No, I have to add. What?
okay, so can you have to keep track of the negative numbers. Okay, so
Yeah, that's where I'm getting so confused. Okay.
yeah, and it's a lot easier if you just keep writing them out. I think that would make it a lot easier. So here's where we're good on negative 24, right?
Yeah.
And we know that from the beginning, we're being told to subtract negative 24 from this fraction, right?
Okay.
So
Okay.
we're
Now I see.
so we're keeping that in mind. So negative 24 minus negative
Negative.
6 over negative 2 gives us negative 24 minus 3.
Okay.
Okay, but
And that wouldn't be negative 21.
no, because the
I was thinking because it's a 3 and it's just notching away at the, like you said, like an account, like a bar tab. And I was thinking, all right, I'm gonna add $3 to your negative account. So that's why I was thinking negative 21. But I see what you're saying there.
I'm trying to think of the best way to. So
No, I see what you're saying now because negative just took over because in actuality it was 3 negative numbers. So it still gotta be
yeah,
negative.
yes. Oh,
Gotcha.
good.
No,
Yeah,
I understand. I see where I was like, I forgot that whole it's 3 negatives. If the negative 24, negative 6, negative 2, those is 3. So that's
yeah,
3 negative.
yeah. Excellent. Very good.
Okay, I got it.
So, yeah, I know it's a little bit confusing the way that they set it up, but I guess just try to keep track of what's happening with the negative number. So once we've divided and we got our, we have our negative 24, which we're subtracting from our fraction, which was positive, right? But you don't just ignore the operation, you don't just ignore the signs, right? So we have a subtraction going on here and then a positive number. So you can just redistribute, think of this as maybe moving the positive sign to the middle here and adding this negative sign to 3. So essentially, you're multiplying this 3 by -1 that's not shown here. Okay, remember we just saw that when you see two signs next to each other, that implies multiplication, right? So -1 times +3 is -3, but we're subtracting, okay? So
Mm-hmm.
-24 minus 3 is the same as adding -24 to -3.
Okay. No, I get it. I've sometimes I gotta talk to myself and then I'm like, oh, okay, I get it. I got it.
Yeah,
I
but
understand that.
I
I
like
see
your
why I went wrong.
yeah, I like your method earlier of taking note of the negative signs as well, right?
Mm-hmm.
Because rules in math always apply, right? So that's
Mm-hmm.
another good way of maybe checking yourself. Okay.
Mm-hmm. Okay.
So more practice questions starting on page 842. All right, so on powers and roots, in the expression 2 raised to the power of 3, the base is 2, and then the exponent is 3. So to raise a number to a certain exponent, you want to write the base number and then the number of times shown by the exponent and then multiply. So here's our 2 is our base, our exponent, or what we're raising 2 by is 3. And so this is just telling you multiply 2 by itself 3 times, okay? To find a square root, think what number times itself equals this number. Powers are a special way to show repeated multiplication. So for example, suppose that you needed to multiply 5 by 5 by 5 by 5. This series of operations can be expressed as 5 to the 4th power, or 5 raised to the power of 4. In other words, 5 appears in the multiplication problem 4 times. So we write the operations algebraically using exponents. In this expression, 5 times 5 times 5 times 5, the number 5 is the base, and our exponent would be 4, right? So multiplying the base, or 5, 4 times. The exponent, a small number written above the above and to the right of the base tells you how many times the base is being repeated. So here's our small number written above and to the right of the base, and it's just telling us how many times the base is being multiplied by itself. In this case, 5 is being multiplied by itself 4 times. So here, 2 raised to the power of 5, or 2 to the 5th power, is simply just 2 times 2 times 2 times 2 times 2, which is 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Okay? Or you could just plug this into your calculator. There's an exponential function. Oh, right here. Can you see this? It looks like a...
Yeah, I see it look like an arrow pointing up.
Yeah, yeah. So this is different because there are cursor keys, right? Which also has an upward arrow, but this one is kind of filled in. Well, not kind of, it is filled in, the filled in triangle. This one is just, looks like a, I don't know if you see one of those Chinese hats that.
Yeah, yeah, yeah. I know what you're talking about.
Okay, so in this example, you would press 2. You'd press 2, and then you would press, where's that symbol? I lost track of it. Okay, you'd press 2, you'd press this symbol, and then you would press 5. Is that 5? Yeah, 5 right there.
Okay,
And then you would get your answer. Okay.
and then hit equal.
Yeah.
Oh, okay. All right, got it.
Okay. So you may encounter some special uses of exponents on the math reasoning test. An exponent can be any positive number, or it can be 0, 1, or a negative number. You want to memorize the situations below. A number raised to the first power equals itself. So 8 raised to the power of 1 is 8. A number other than 0 raised to the power of 0 equals 1. So 0 raised to the power of 0 is 0, but 1 raised to the power of 0 is 1. 2 raised to the power of 0 is 1. 6 raised to the power of 0 is 1. A million raised to the power of 0 is 1. So any number other than 0 raised to the power of 0 is 1. Okay. 0 is the exception. A number raised to a negative exponent is equal to a fraction with a numerator of 1. So let me zoom in so you can see this. This is 4 raised to the power of negative 2, and you would just rewrite that as 1 over 4 squared. 4 times 4 is 16, so your answer is 1/16. If this was, let's say, negative 3, then you would rewrite that as 1 over 4 cubed, or 4 raised to the power of 3, which is 4 times 4 times 4. 16 times 4, 64. 4 cubed is 64. But anyway, 4 raised to the power of any negative number is just simply 1 over the base and the exponent without the negative sign. Okay, that's a simple way of thinking about it. Make a list of common square roots by squaring the numbers from 1 to 15 and then memorize them. You'll need to know common square roots to solve geometry problems about area and right triangles. So I pulled this off of geeks.org. It's telling you to memorize up to 15. This one goes up to 30. But these are just showing you the squares of numbers up to 30. Okay. You can use your calculator to raise numbers to any power. You can use the x squared key, or you can use this is the key that I was showing you earlier. So it's right below that symbol. So here's x squared. So you can use either one of those keys to find exponents. To find the square of 24, you would press 24 and then the x squared key and press enter, and you would see your display. Or you would enter 24, use this symbol, and then 2, The square is always 2. So you would write 24, press this key, and then 2, and you would get the same answer. Essentially 24 times 24, right? To find the value of 9 raised to the power 4, enter the base, which is 9, and then press the symbol indicating your exponent, and then press the relevant exponent, which in this case is 4. So 9 raised to the power 4, press enter, and you get your answer. To raise a negative number to a power using your calculator, you must enter the number in parentheses. If you don't do that, the calculator is going to assume, let me zoom in. If you don't enter the parentheses, the calculator is going to assume that you're asking it to raise a positive 4 to the power of 2. And that goes back to the example we were looking at with the numbers in the row. And then we worked on our operations, and you're like, well, what's going on here? Shouldn't this be negative 21? It's following a mathematical principle called BODMAS or PEMS. And I didn't want to mention that because it's not mentioned in the book. And I think I try not to add information that would complicate the lesson. But you always want to, if you have a negative number, you always want to put that negative number in parentheses before you use the exponential operation. Otherwise, your answer is going to be wrong. All right. You want to make sure that the calculator is taking into account the fact that there's a negative sign associated with that number. To square a number, multiply the number by itself. For example, 6 squared, 6 times 6, we already covered this. In expressions, 6 times 6 is 36. The number 36 is the square, and the number 6 is the square root, okay? That just goes back to the earlier note that was telling you, ask yourself, what did I have to multiply this number by to get 36, right? Well, you multiplied 6 by itself twice. So 6 squared, 6 being the base, 2 being the exponent, 6 squared is 6 times 6, which is 36. And the square root of 36, or the number that you have to multiply by itself to get 36, is 6. Okay. The symbol for the square root is this right here. So to find a square root, think what number multiplied by itself is equal to the number in the bracket. Okay, as we just discussed. So here, told to find the value of the square root of 144. You know that 12 times 12 is 144. So the square root of 144 is 12. So although negative 12 times negative 12 is also equal to 144, you'll only be expected to find positive square roots on the GED test. You may have to approximate the value of a square root. So for example, you're being told to find the square root of 90. We know that 9 times 9 is 81, and 10 times 10 is 100. And since 90 is between 81 and 100, the square root of 90 will also be between 9 and 10. Okay, so you can use your calculator to find the square root. First, you have to press the second function key, and then the square root key, which is directly above the exponent key or the x squared key. Other calculators may not require the use of the second function key. So in other calculators, you might see the square root key as a raised key that you can just press on its own. With this particular calculator, you have to press the second function key first. So use your calculator to find the square root of 90 to the nearest tenth. You press the second function key, then the x squared key, and then press enter. And the right side of the display would read 3 times the square root of 10. 3 times the square root of 10 is essentially just 3 times 3.162, which works out to approximately 9.5. Or you can press the toggle key, and that will change the format of your answer, this format right here, into a decimal. So if you don't want to bother with then finding out the square root of 10, you can just press the toggle key, and that will give you 9.5, the same answer, rounding to the nearest tenth place. Okay. On to lesson 3, which is on scientific notation. In scientific notation, a number equal to or greater than 1 and less than 10 is multiplied by a power of 10. And you'll see what that means shortly. Very small numbers are expressed by multiplying by a negative power of 10. In scientific notation, the number with the greatest power of 10 has the greatest value. So for example, if you were comparing 3 raised to the power of 2 and 4 raised to the power of 9, because 4 has the greatest power, when you work out that exponent, the answer that you find will be the greatest number. Okay, should I repeat that?
Yeah.
Let me give a different example. Let's say you're looking at two exponential numbers and you're trying to figure out which one is the largest. Okay, the test is asking you 6 raised to the power of 4 and 5 raised to the power of 9. Which of these two is the largest? Because 9 is larger than 4, 5 raised to the power of 9 will give you the greatest answer. Okay, that's all this is saying, is that the number with the greatest power of 10 has the greatest value.
Okay.
The power of 10 being the exponent. Okay.
Okay.
Yeah. And there are examples coming up, so I think that will make that clearer. Scientific notation uses powers of 10 to express very small and very large numbers. In scientific notation, a decimal number greater than or equal to 1 and less than 10 is multiplied by a power of 10. And we'll see examples coming up. I added this in green because I thought it might make this a little bit easier to understand. So you want to look for patterns as you review powers of 10. And so again, a power of 10 is any base that's raised to an exponent within this range. So here, it's telling you to look for patterns as you review powers of 10. 10 raised to the power of 1 is 10.0, and 10.0 is 10. 10 raised to the power of negative 1 is 1 over 10 raised to the power of 1, which is the same as 1 over 10, or 0.1. Remember our lesson on decimals and decimal equivalents and that chart that the book asked you to memorize. 1 over 10 is the fractional equivalent of 0.1 in decimal form. Okay, so it's telling you to look for patterns in powers of 10. In the row with the positive exponents, so here we have a positive exponent. The exponent is the same as the number of zeros written in standard form. One exponent here, and so the number of zeros after the decimal point, there's only 1 0, okay? In the row with the negative exponents, the exponent is the same as the number of decimal places in the number. So here we have 10 raised to a negative number. And if you see here, our decimal place is exactly 1 decimal place after the decimal point. Okay, so is it clear? Well, I think
Yeah. I'm getting the hang of it.
okay, I think there are better examples in this coming up.
Okay.
In this example, you're being asked to write 6.2 standard form, right? So basically as a regular number, okay? That's what standard form means. So without using our calculator, we look at our power of 10, 5, and we see that it's got, since we're raising to the power of 5, the number of decimal places after we've multiplied this power of 10 by this number will also have 5. So 6.2 times 10 raised to the power of 5, you would count until you have 5 decimal places to the right. And then in those places, you would fill in zeros until you have reached your 5th place. And so the answer is 620,000. And if we go back to here, that's all this was trying to tell you, but I think it wasn't clear because one is one decimal place over to the right, you don't really see.
Exactly.
Right?
The other made it so much more clear.
Yeah. Yeah. So here in example 2, we're being told to write 3.82 times 10 to the negative 3 in standard form. So this time around, we're going to move 3 decimal places over to the left. So you would start where our decimal point was right here, and we would count 1, 2, 3, and then place our decimal point here in its new position, and then fill in zeros in the empty spots until our answer is 0.00382. And that is consistent with if you were to think of this in terms of 10 raised to the negative 3 as 1 over 10 raised to the third power, then we would be multiplying 3.82 times 1 over 10 raised to the third power. And you remember from our lesson on multiplying fractions, we multiply across. So 3.82 times 1 is 3.82. And then this number in fractional form is 3.82 over 1. So in our denominator, we would have 1 times 10, the 10 coming from this here being in our denominator. 10 raised to the negative 3 is now 1 over 1 over 10 raised to the third power. So again, multiplying across, 3.82 times 1 is 3.82. Dealing with exponents that you have to write in standard form, just remember that, again, if your exponent is positive, you move your decimal point over to the right by the same number of places in the exponent. And if your exponent is negative, you move your decimal point over to the left by the same number of places in the exponent.
Okay.
Okay. Here's a test tip. Always try to save time. Suppose the multiple choice answers are written in scientific notation. Instead of changing each choice to standard notation, just change your answer to scientific notation. You want to work backwards to write large and small numbers in scientific notation. Scientific notation is this form right here, where you have either a whole number or some form of decimal being multiplied by 10 raised to an exponent that's within that range that we just discussed. 1 in itself and not including 10. And it doesn't include 10 because then you start dealing with logarithms, which is a completely different topic. But I wanted to mention that in case it helps to make it easier. Why are we not including 10? Because then we start dealing with a completely different. It's just telling you here to work backwards to write large and small numbers when you're dealing with scientific notation. So for example, to reach Mars, the Viking 2 spacecraft traveled 440 million miles. What is the distance traveled in scientific notation? So what you want to do is, I think before I say that, anytime you see a whole number, I think we discussed this already, but I just wanted to mention it really quickly before we continue with this example because I think it might make it clearer. Anytime you see a whole number, always know that there's an imaginary decimal point with zeros after it continuing into infinity. Okay, so there's an imaginary decimal point here after this 440 million. Okay, so to write this 440 million in scientific notation, we simply move our decimal point over as many places as are present in the number until you reach the single digit to the left of the decimal point. So we carry our imaginary decimal point 1, 2, 3, 4, 5, 6, 7, 8 places over to the left. And so 440 million can be written in scientific notation as 4.4 times 10 to the power of 8. Okay, so that's what this is telling you here. Work backwards to write large and small numbers in scientific notation. Backwards meaning take your imaginary decimal point and then move it over however many places until you get to the single digit to the left of the decimal point. In this case, it's 4. And then you just count the number of values that you have, and then you would report the first number as a whole number to the first decimal place, in this case 4.4, times the number of places that you moved, which in this case was 8. Okay. And if it helps, you can just, so for example, let's say you own a cake shop, okay, and your cakes, the price of your cakes are 40 bucks, okay, and you want to give a receipt to somebody, and you write, they give you $40, but your receipt machine happens to not work. It's not working for that transaction. So you write down $40 on a piece of paper, and you hand that receipt. You write down paid $40, and you hand that receipt over to the customer. If that same customer comes back the next day and your receipt machine is now working, and you print a receipt that shows 40.00 and you hand that receipt over to the customer, both receipts are valid, right? But they're just written in different ways. The first one had no decimal places, but it's still representing the same number or the same price that you charge for your cakes. And the second receipt shows only two decimal places over to the right, but it's still, you charged the customer, or it's still reflecting the fact that you charged your customer the same amount, okay? All this, so when this is telling you to work backwards, it's telling you that when you're dealing with a whole number, take that decimal point, that imaginary decimal point, and then work backwards until you reach the number that only has a single digit over to the right. You stop right here, and then you would report your number as 4.4, or your scientific notation as 4.4 times 10 raised to however many places that you moved your decimal place. Okay? In this case, that happens to be 8.
Yeah, okay.
Okay. In this example, we're told that scientists find that a kind of bacteria moves at a rate of 0.00016 kilometers per hour. Write the measurement in scientific notation. This time around, let me zoom in. We can see our decimal point clearly, right? So we're going to take that decimal point and we're going to move it 1, 2, 3, 4. We're going to stop here because now we have, you can think of it as a whole number 1.6, okay? And then you ask yourself, well, how many places to the right did we move our decimal point? Well, we moved our decimal point 4 places over to the right. But since we moved to the right, our exponent is going to be negative. And that's just ensuring that when you put this number into your calculator, you arrive at this original value. Okay, and remember, another way to think of this 1.6 times 10 raised to the power of -4 is that we're multiplying 1.6 by 1 over 10 raised to the power of 4. Is this value right here, 0.00016. A good rule of thumb, or a good way to remember this, is that if you're moving your decimal point to the left, your exponent is going to be positive. If you're moving your decimal point over to the right, your exponent is going to be negative. You may be asked to compare numbers in scientific notation. And so this is what I was trying to explain earlier with the example I was giving, where you're trying to determine, okay, which of these is greater? So in this particular example, we have 4.5 times 10 raised to the power of 3, and then we have 9.8 times 10 raised to the power of 4, and you need to determine which of these is greater. Well, you just, you don't need to change the numbers to standard notation. You would just simply consider the powers of 10, right? We know that 10 raised to the power of 4 is 10,000, and 10 raised to the power of 3 is 1,000. So this number would be greater, right? Or it would have the greatest result, since we're multiplying 9.8 by 10,000 versus 4.5 multiplied by 1,000. In scientific notation, the number with the greater power of 10 has the greatest value. And again, remember, we established that a power of 10 is 10 raised to any number that's within that range of 1 and 10, but not including 10. 9.8 times 10 raised to the power of 4 is greater than 4.5 times 10 raised to the power of 3 by reason of the logic that we just established here, or you can just put both numbers into your calculator and determine which one is greater. But you know, the test tip earlier was telling you that you want to save time. So looking at these two numbers, you should just recognize immediately that this one is greater, because why? It has the greater power. It has the greatest power. But if there's anything that you want us to discuss, we can always go back to any of the slides. When you see the term scientific notation, just know that we're talking about a whole number or a decimal number being multiplied by a power of 10. Okay, so
Okay.
and it'll always look something like this. Okay. And that's all scientific notation means. And if you're asked to express scientific notation in standard form, know that you're being asked to take a number that looks like this and write it as a regular number that you would see every day, like 440 million, for example. Okay. And if you're being told to take a number that's in standard form and write it in scientific notation, know that you're taking a regular number that you deal with often, and you're being asked to express it as a decimal or a whole number. Either when I say decimal or whole number, on this side, you would see something like 4.4, or you might just see 4 multiplied by a power of 10. Okay. And when I say power of 10, 10 to the power of 1 or 10 to the power of 2, continuing up. Okay.
Yeah.
All right, cool. So that's essentially it for today's lesson. Work on the practice problems. If you have any questions, let me know. Other than that, I'll see you on